Hello guys, hello everybody. Hello, every parts of the world. Welcome back to my wifey channel. Okay, this time I'm going to be able to uh, have a topic regarding rate of appearance and rate of disappearance, or basically the rate of chemical reaction without involving experimental data results. So what I mean here is that we refer only directly to the chemical reactions involved in that particular problem. Okay? It's very clear. Okay, so you can get now your blank sheet of paper, okay, to solve also this kind of problem. Okay, so I have here problems. Actually, I need to, prepare various problems for you guys to really learn how to solve this. I really prepared last night, okay, for this. Okay, so green color. Oh my God. Green color is a symbol for being an environmentalist. Okay, green. Okay, something like that. Okay, now the problem states that calculate the overall reaction rate of 2 moles of dinitrogen oxide gas. The laughing gas plus 3 moles oxygen gas is equals to 4 moles of nitrous dioxide. Shall we say nitrogen dioxide? The rate of disappearance of nitrogen dioxide is 7.34 times 10 to negative 3 molar per minute. Okay, here the time is minute. So it doesn't matter, it depends as long as it is a time. So this is a rate. Okay, now we need to write the data. Okay, before that, take a closer look to the problem and then analyze by yourself and take note the data and then think and appropriate formulas and equations to this. Okay, so it's very clear the chemical reactions are presented already in the problem. You don't have to worry, but you have to check if it is balanced or not, the chemical reaction. Inspect visually the reactants and the product, like that. Check the number of atoms if it is balanced. So that's the first procedure if you are having a chemical reaction, because it has a purpose somewhere along the way. Okay, especially if your problems are not experimental based. There's no table, there's no presentation of various quantities in the table, or there's no graph, something like that. But in here, there's a purpose for this, why chemical reaction is given. Okay, we are very lucky that there's a chemical formula, like that, and all we have to do is to check. Okay, so let's put first the data, the first step. But actually, guys, as far as I could remember when I was in college, the first step really is to identify what is being asked or what is being required. For example, the rate of the appearance of an O2 is like this, that is, what is the overall reaction rate? So our first step is to obtain what is being asked in the problem. Okay, something like that. So we follow the sequence of problem solving. Okay, but actually it depends on your comfort zone or convenience what to do. But I'm just trying to follow the proper formatting of problem solving. Number one, you need to write what is being asked or what is the required for that particular problem. So the required number one is it's only the overall reaction order. Overall reaction order. Okay, like that. So in this case, if it is taking overall reaction order, you still have to get the reaction order of each, okay, of each reactant. Okay, And then total is the overall reaction order. Number two, you need to calculate the overall reaction rate. Oh my gosh. Overall reaction rate. Okay, so the rate and order are being asked in the problem. So remember, this is an overall reaction rate, meaning we need to compute for the R, not only for the reactant, second reactant, the overall. How can we do this? Later I will explain to you something new for this. Okay? But still, the principle and concept is still the same. Okay? Now, we need to put now the data. Okay, the rate of disappearance. So this is the rate. So R of NO2. Okay, is data given. Okay, given. Number two, given. Number one, required. None. Okay, guys. Okay, given is 7.34 times 10 to the negative 3 molar per minute. Okay, this guys. So if you have this 7.34 molar per minute, this is just equal to 7.34 times 10 to the negative 3 moles per liter minute, because molar is moles per liter. Okay, this is an expression, a measurement of the expression of the concentration, the same as molality, normality, and basically in general the solubility we are referring to, the concentration. Okay, now we need to break that up. Okay, so it's gonna be moles per liter. Okay, and minutes. Our purpose really is to make it specific. Okay, because this capital M molar, this specific capital M molar has no contribution in the actual stoichiometric relationship in the chemical reactions involved. Because I told you a while ago, this is not an experimental type of problem solving in kinetics. This is more related to the direct, okay, in the chemical reactions presented in the problem. Okay, so that's gonna be the situation now. Okay, another given, the chemical reactions. Okay, and good, this has been presented. Okay, so 2 moles of dinitrogen oxide gas. Guys, dinitrogen oxide is also known as a laughing gas. Okay, maybe it will come out in the examination. Blanc is known as a laughing gas. Your answer will be dinitrogen oxide. Just like blanc is a natural gas, your answer will be methane, CH4. Just like this. Some problems in the future will be like this also. You should identify the other name of that particular compound. And there, for example, a blanc is known as a muriatic acid. Okay, then this is used in cleaning the toilet to remove the stains and corroded tiles. This is known as hydrochloric acid only. Okay, something like that. Blanc is known as aquaxinada. Aquaxinada, something like that. So that is also called hydrogen peroxide, H2O2. Okay, like that. So blanc is having the formula of 3 atoms of oxygen exist as O3. So oxygen 3. So that is ozone. Okay, so the other forms of oxygen. Okay, there will be an oxygen gas, and there's also an O3, which is an ozone. Things like that will sometimes come out in the examination. Okay, and you should be clever and smart enough to remember and detect those, basic concepts in chemistry. Okay, something like that. So 2 moles of dinitrogen oxide gas plus, okay, 3 moles of oxygen. Okay, so if you try to remember the properties of each gas involved in this chemical reaction, okay, nitrogen reacted with oxygen. Nitrogen is reactive to the gas also, but it never reacts to the metals. Okay, because nitrogen is an inert gas, non-reactive. Okay, and oxygen is highly reactive. That's why they are going with each other. Gas plus gas will become N2O. Okay, because oxygen is very reactive. Okay, something like that. Not stable. Okay, but nitrogen is really non-reactive. But since these two are gases, then bingo, they will react with each other. The same principle with the atmospheric condition that God gave to us. Okay, nitrogen gas plus oxygen gas is equal to the unideal air. 79% by volume of nitrogen plus 21% by volume of oxygen is equal to the atmosphere ideally. Okay, but now it is not already like that. There's a lot of gases involved now in our atmospheric environment, atmospheric conditions like the greenhouse gases, carbon monoxides, carbon dioxides, okay, nitrous oxides, sulfuric dioxide, and a lot more gases involved. Okay, so these are all gases. So you don't have to. Okay, now it will produce 4 moles of nitrogen dioxide. Okay, you should not put headache on your mind, guys, because this is only one elementary chemical reaction. This is not a reaction mechanism that you have to break down each elementary reaction steps and then sum that later on. It's not. It's not mentioned in the problem. Okay, sometimes things like that you don't have to complicate. Okay, so we have now. So how can we compute this by this visualization only through 2 data involved? First, the rate of its appearance of this, what you call this one, NO2, and then the chemical reactions involved. Okay, so we go back to the concept of rate, concentration, or rate, or chemical reaction rate. Okay, so I have to discuss a little bit so that we can answer this properly. Okay, because this is unique. Meaning unique, this is not being told all the time. Okay, meaning to say, it will just appear like this in the problem, but there is no exact formula how to use this. You know what I mean? CHE calculations or stoichiometry relationship is not like that. There's a standard formula to be used. You have to use your, what do you call this one? Your senses, your logic, employing those basic concepts and applying the basic, some little basic formula, but not necessarily, okay? And then you can compute already, something like that. So that's what I've learned in my, in my chemical engineering entire course, okay? You didn't have to memorize the formula because, it is independent really all the time, okay? You're using your basic logic to compute calculate in this type of equations. And most of this type of equation problem solving will be in the chemical calculations or in the stoichiometry subject. Okay, something like that. So this is not difficult really. Okay, so we have now like this. So 7.34 times 10 to negative 3 molar per minute, or shall we say mole per liter per minute. Okay, we'll transfer that here. So this is for in O2. So delta change. Guys, if we talk about delta, there are 2 ways to express it. It could be a small letter D or a triangle symbol. Okay, and Greek symbol. Okay, used by our scientists before. But it's up to you what nomenclature you will be able to use. Am I right? Nomenclature. Okay, D. So D, NO2, okay, gas over dt. So this is the rate. There is always denominator time, okay, if we talk about the rate, okay, and this is also the concentration, okay, like the reaction rate. So it's given 7.34 like this, okay, times 10 to the negative 3 mole liter per minute. Okay. If it is minute already, you don't have to convert that one unless the choices in the examination is in seconds. Okay? But if it is still in minute, you don't have to worry. Okay? Put that as is. Okay? Like that. Okay, now, this one, I can put that N2O. I have to illustrate or specify also the rate of disappearance of the N2O and the oxygen gas, the same as the problem also presented the rate of disappearance of NO2 so that it will be equal, okay, in the equilibrium stage, okay, as per law of conservation of matter. Okay, so so that it will be balanced. Okay, like that. But before doing that, we will check the number of moles, atoms, if it is balanced already by visual inspection. We don't have to go with the algebraic expression because it will take time for us as long as we understand really how to balance the chemical equation. So inspect individually. Nitrogen, 4 moles in the 4 atoms in the reactant, 4 atoms in the product. Oxygen, 2 plus 6, 8. Okay, balance, bingo. Because there are 2 elements only, which is specifically a gases, the nitrogen and the oxygen. So totally balanced. So proceed. Okay, going back to the rate. Okay, if the rate of the NO2 is given, then we need also to obtain the rate of the other two to establish equilibrium. Always that have in your brain cells. It's gonna be like that. Okay, because most of the stoichiometric relationship abiding the law of conservation of matter, meaning equilibrium, steady state. Okay, meaning we have to equate 1.1.2.3 and then blah blah blah, the rest will follow. And then if you know logic, then you can solve what is being required. Something like that. It doesn't have to be difficult. Okay, but sometimes the problems presented are difficult to watch, but actually it's easy to solve. Okay, that's one pressure by the examinees in the future. If you try to look, it looks like difficult, but actually if you try to solve it, it's not difficult. That's number one. Okay, your greatest enemy is your psychology and fear in taking the examinations because you always think difficult. But it's not really difficult if you try to attempt to solve it, applying your logic, your senses, IQ, your stock knowledge, something like that. Okay, you know what I mean. Okay, going back. So D and O2 we have already for our rate for the in O2. Now we have to get also the rate of dinitrogen oxide. So this is gonna be D. Okay, DN2O. So our purpose really is to balance mangut siya. That's why we need to get the also the reactants. Okay, DN2O over DT. Okay. Now, guys, the N2O will dissociate when it will be producing a product, meaning it will be a negative concentration already because it will be reduced. The initial concentration of N2O will be reduced, it will become negative, so that to produce this NO2. So that is having a negative rate. Okay, so negatives, which we don't know yet. Okay, so put negative beside this N2O, and you have to put question mark. What is this all about? Let's say this is X. Okay, because you don't know. Let the value of X as the rate of N2O per time because you don't know yet. So X. A little bit algebra. Okay, and then for the oxygen gas, again the same story. DO2 gas over DT. So DO2 gas over DT. So still negative. Yes, still negative because it will also dissociate to produce a product. Okay, like this. Okay, okay. I will have Y. If you put a certain variable or letter to a certain quantity, okay, then put another representation of another letter so that you will not be confused somewhere along the way of your computation and solution. Something like that. Okay, now going back to the basic computation of this specific problem. Okay, there are two ways how to solve this. Okay, first you go directly to the stoichiometric relationship in which you don't have to worry the fractional form of number of moles, meaning if this will reacted to this, how much is produced moles to the product, like that. So there's a relationship. So that's another thing. If you want this direct stoichiometric, then you can go. And the other also, you can also go. But the basic theories discussed in this other one, not the direct stoichiometry. Okay, let's go first to the first. method, the direct. Okay, the direct way of solving this problem. Okay, now since we have 7.34 times 10 to the negative 3 moles per liter per minute. So that is your basis of calculation. Okay, this is what we know as the basis of your calculation. In any problem solving related to chemistry, physics, thermodynamics, or sciences, you have to have always your basis of calculation in which that is also presented in the problems given. Okay, so here, our basis of calculation, but it depends on the situation, okay, especially for the percentage by volume, percentage by mass, in which you will refer always 100 grams, 100 ml. Okay, it depends on the situation, but in here, this is not really focusing to that aspect. It's really different because this is chemical reactions. Okay, this is not physical. Chemical reactions. Okay, like that. So 7.34 for solution proper na ka. 7.34 times 10 to the negative 3. Okay, moles per liter minute. Okay guys, our moles guys are stated in MOL only ha, to make it short abbreviation, MOL. Okay, this one. Now, consider the stoichiometric relationship in this basis of your calculation. So, how many moles of N2O that will react here in your chemical reaction? How many moles of N2O that will react to oxygen to produce 4 moles of nitrous dioxide? It's very clear in our stoichiometric relationship that we have 2 moles of N2O to react to produce the product. Now, you will apply that here in your multiplication process. Okay, since you are using NO2, your denominator always will be the number of moles of NO2 to cancel that out somewhere along with your solution. It's not the reverse or else it will not be cancelled at all. That's basic concept in algebra. Okay, so moles NO2 over moles of NO2. How many NO2 here? Okay, in the product. So 4 moles of NO2. Imong is what? So 4 moles. Okay, 4 moles of NO2. Never mind the phase because we are not concerned here with the phase. PHASE because this is an NO2 gas. But in the thermodynamics, we are concerned with the gas, with the liquid because those phases have different standard heat of formations or standard heat of enthalpies. But here, doesn't matter the phases. Focus on the quantitative relationship of the number of moles, number of atoms, like that, the rates, and chuba chuchu. Okay, so 4 moles of NO2 in the denominator. Then, since you are solving for the dinitrogen oxide N2O, then the number of moles of N2O will be in the numerator. Okay, now, how many moles of N2O in the numerator? Okay, so that is 2 moles. So write that out here. So 2 moles of N2O. So cancels the moles of NO2. What's being left is the moles of N2O liters per minute. So this is our bingo. This is our rate of disappearance of dinitrogen oxide automatically through our basis of calculation, which is 7.34 times 10 to the negative 3 molar per minute or moles per liter minute. Something like that. So this is, ato na siyang ibutang sa X because we already solved that out. So, okay na. So there will be no X anymore. It has been computed already. Then put that there. So, calculator please. Okay, something like that. So, now in my case, guys, okay, wait for a while. I have to, adjust the settings. Sorry. Give me 2 minutes. Okay, like that. Okay, wait for a while, guys, ha? Okay, something wrong. Okay. So, calculator. Okay. In my case, guys, when I was in college, I really need to avoid exponents. So all I have to do is to move it from the left, if it is negative, or something like to the right, if it's positive, something like that. I follow that rule so that it's easy for me to calculate. Okay, because if I keep on using this one, and then sometimes due to pressing the calculator, sometimes it is not really also, practical. Maybe it will wrong sometimes in the first press, the second press it will correct. So sometimes the calculator also is like that. I don't know what's the reason for that. Maybe the pressure of your hand or fingers. I don't know. Okay, because you're too much in hurry. Okay, but for me, I avoid that one. To avoid exponents is to move the zeros in the left, right, something like that, or whatever. Okay, then we can solve it in a numerical figure, not talaga siya. Okay? That's it. You know, guys? Okay. Now, calculator, please. So, point zero, okay. 0.00734, which is the same as 7.34 times 10 to the negative 3. Move it from the left because it's negative exponent. Okay, times 2 is equals to, okay, how much is your moles of N2O? Sorry, it is 4 moles of N2O. Be careful also here, in putting the number of moles. Okay, normal mistake to the individual examinees or students, we keep solve very fast and then we missed to put the exact number of moles in our calculation, which is a normal error to all, not only for me, for you, for everybody, especially we are in hurry. Okay, that's what do you call this one? Natural process of errors. Okay, sometimes it could not be denied. That's mistakes of all, not only for one individual. Okay, I'm telling you to be careful to put that exactly what is the number of moles here in the chemical reaction. Just now also I put 2 moles of N2O due to my excitement also in this kind of lacking. Okay, there's a lot of factors why we commit errors. Okay, okay, something like that. So and we don't have to explain that much. Okay, okay, going back. So 4 times 0.0734. So this is, okay, like this. I-divide mo siya. So 2 divided by 4 is equals to times 0.00734. It's equals to 3.67 times 10 to negative 3. Guys, what do you this one? Weakness. Okay, my weakness really, guys, is when I kept on talking, I will commit errors in my solutions. Okay, that's my usual mistake. And then number 2, common errors are due to erasures. Okay, number 3, very fast in presenting the 1, 2, 3, 4 like this. And number 5, errors because I solved on the spot. I did not prepare. Okay, because if I prepare this, it turns out to be perfect. No need of erasures, no need to change the number of moles because I already studied how it is being solved. But that's not the real story. The real score is I have to present in on the spot manner. I study the principles and concepts, but I'll never go to how it is being solved. Okay? And then later I will watch it if it is correct. Okay? Something like that. Because if that is the case, you will always memorize how it is being solved. In my part really as a chemical engineer, it is not a challenge for me. Okay? Because I've done that in the past for my 5 years. Okay? Plus 1 year in my review. I took the review for 1 year. Okay? Plus 1 year in my review. And then it took me 6 years in BS chemical engineering. But then I will just watch how it is being solved. So it looks like an insult for my part. Okay. It looks like a joke, but for me that's my style. Okay, I have to solve it first and then compare if it's correct or not. Okay, though I have the stock knowledge of the theories and the principles, and then if I am wrong, I have to read, oh, this is that. But I never go to the details of the problem solving. Okay? Really, because I don't like also, because I said to you a while ago, I don't love really mathematics. Okay? I don't really love mathematics. I've just studied mathematics a lot because it is a part of my profession. It is a part always in science, in studying science. But if I have a choice, if there's no numbers, I don't have to deal with numbers. Really. As you can see, the way how I talked, the way how I communicate. So Not all can talk like this. Because if people are good in mathematics, cannot talk very much in English also. Okay, that's why they said most of the engineers can talk very well. Okay, only the journalism courses, okay, the College of Arts and Sciences can talk very fast as this. But me, I am the reverse. I can talk very fast and very well in English communication, even though I am an engineer. Okay? Because they said most of the engineers can't talk very well spontaneously in English. But it is not true for me in my part. Okay, going back to the solution. Okay, I have now 3.67 times 10 to the negative 3 moles of N2O over liter minute, something like that. Okay, you have to put the unit, of course, in your answer. Okay, moles like this, N2O liter per minute. Pasensyahan lang ko ninyo guys ha. I will never go to the most difficult problem solving really. Okay? Maglibog na yun ko. I have to be honest. Okay? So 3.67 times 10 to the negative 3 moles N2O per liter minute. Okay? This one. I can guarantee only average, above average, a little bit difficult, but not difficult, but not very difficult, something like that. And my solving of problems. But others also like to solve very difficult problems, especially to those people that are good in mathematics. Okay, very good in mathematical ability, they love that also. Me, the reverse. I don't like really. Okay, so this is the example. 3.67 times 10 to the negative 3 moles of N2O per liter per minute. Liter minute, something like that, okay? So we have now. Then, atong ibutang, we should put that here because we treat that as an X. Guys, be careful. Okay, N2O in a problem that is in the reactant. Remember, the reactant will be reduced and will decrease somewhere along the way. So this is the rate of disappearance. So automatically this is negative 7.34. Negative 7.34 times 10 to the negative 3 moles, okay, per liter minute of N2O. We solved already the X. How about the Y? Okay, how about the Y? 3.67 like this. We solved that already here, ha? Okay, ganon. So how about the Y, guys? The rate of disappearance of oxygen, which is also expected to be a negative sign. So the same story, your basis of calculation is still the NO2, the same how you solve the N2O. Okay, like that. So 7.34. I don't have to put the units anymore, because it's very self-explanatory. Okay, 7.34 times 10 to negative 3, direct multiply, because already understood that the units are just the same. Okay, so your denominator for the oxygen gas, of course, is the oxygen gas. Okay, so what is the mole of oxygen gas in your chemical reaction? So 3 moles. So put that in the denominator. So 3. No putting of the units because it's just the same principle with the first. Okay, and then what is your numerator for this? Denominator is 3. Numerator will be the one you are being asking for. Okay? Sorry, this is 4, not 3. So you're very excited, right? Immediately corrected by, quick thinking. Okay, so 4 is the denominator, sorry. Okay, that's why I told you, if you understand, you can easily correct that on the spot. Okay, so 4 in the denominator, and then in the numerator will be the 3 of oxygen. I'm very excited really. Okay, 3 is in the 3 moles of oxygen gas in the numerator. So divided this, guys, very easy, even though a grade school level or an elementary student can solve this. A fraction times an exponential, this is negative 3 also. Okay, so 3 divided by 4, okay, times 0.00734 is equal to 5.505 times 10 to the negative 3, or it is equal to 0.005505 negative sign, because oxygen gas initial concentration will be reduced to help produce the 4 moles of NO2 together with the N2O in your chemical reaction. Okay, so this is negative. Okay, negative. Okay, negative 5.505 times 10 to the negative 3. The unit is also the same. Moles, liter, minute, oxygen gas. Okay, something like that. So we now solve the concentration over time of oxygen gas, and we need to put now in the y, because we left y as our rate of disappearance of oxygen gas, and now we computed already, so put that there and carry the sign. Okay, negative 505 times 10 to the negative 3 moles liter per minute. Oh, ganon. So, we computed already the x and y, which both our rate of disappearance of your reactants. Does it satisfy in our required? The questions are, what are the overall reaction order? What is the overall reaction rate? It doesn't yet satisfy, right? So how can we do that? Okay, so we still have to undergo the summation supposedly. So by normal mathematics, we need to add, right? Rate of disappearance plus rate of disappearance of N2O plus rate of disappearance of oxygen gas plus rate of the disappearance of NO2. But it is not correct because NO2 is not part of the reactant. So that principle is correct and incorrect. Number 2 principle, we have to add the overall reaction order of oxygen and N2O. Okay, rate of disappearance of N2O plus rate of disappearance of oxygen gas is equal to the overall reaction. How about the NO2? It's separate in the reaction, so you cannot apply this one also. So wrong. So how can you do this? You cannot sum it up. It deviates in simple algebra that you have to sum only. Okay, the quantities, sum of the one component, sum of two components, so it is the total. And if it is an average, divided by the total of how many. That's why we have average. Okay, but total is just a total. You don't have to divide how many. Okay, but this is overall, meaning total. Okay, but if you add this concept will never apply here. How can we do that here? Since we have now the three rate. Okay, the three rates that we already have. In the problem, we have 7.34 times 10 to the negative 3 molar per minute of NO2. And then we computed already the rate of disappearances of this N2O and oxygen gas already. There are 3 already, then supposedly we can add directly, right? But we cannot do that due to that reasons. What can we do now? Hala. So this is I'm going to teach you. Okay, so overall reaction order. Then you cannot also, another number 3 also reason. You cannot use also the rate law, which is K. Okay, if I will show you the rate law, this is really sometimes, if the students will not think, then you will be confused also. Okay, so R rate law is equals to K. If you try to use the rate law of reaction mechanism or the chemical reaction kinetics, which is really the focus on the center of the study. So we have R is equals to K, close and open parenthesis, the rate of N2O raised to the power X, which is our reaction order with respect to N2O. So we have raised to the power X times oxygen gas raised to the power Y. Okay, this one is our standard overall reaction order, supposedly. R is equals to the rate constant times the N2O raised to the power X times oxygen gas raised to the power 3. Oh no, it's not power 3, raised to the power Y. Because the reaction order is not the same as the number of moles. Wow. Okay, something like that. So can we use this also to answer what is the overall rate of reaction? Because small r is the overall rate of reaction, actually. Still, we cannot use this. Why? Because we don't have rate constant in the problem. And then, another reason, the problem is not done experimentally. Okay, there's no table to present the initial concentrations. This is more on stoichiometric relationship by basing the chemical reactions only. So the two analyses you have in your brain cells will be failing or failure. So what is the last analysis to be used for this? To have the overall reaction rate. Okay. Now we think of another one which is standard for all, which is it is gases, solids, and liquids. We treat 1 mole. Really, ganun talaga yung chemical engineer. Bigyan talaga ang chemical reactions or studying chemical reaction engineering. Just like ideal gas. So we go back to the basic. Okay, just like the thermodynamics. Actually, they are having both standard basic foundation talaga siya. Okay, so you remember in ideal gas law, in a general gas equation, that we treat 1 mole of an ideal air. Okay, we treat 1 mole of an ideal air so that, by Dalton's law specifically, so that it will occupy a 22.414 liters of gas by volume. Right, remember Dalton's law. Okay, it's just also the same here. It will be applied, but the phase is not a gas. The phase is a concentrations, could either be a liquid or solid or a gas. It just happens here that these are all gases because oxygen and into, but it can also be applied to solids, liquids, something like that. Okay, I'll never intentionally do this to choose just to be applied. It's just because this kind of problem I already chosen. Okay, it just happened really. Nobody wants to solve complicated theories like that. Okay, like this. Now we treat also 1 mole of chemical reaction. Ala. The same as what we did as 1 mole of an ideal gas. The same thing. So 1 mole of chemical reaction is just the same as 1 mole of overall rate chemical reaction of these components. We have to do this individually. Okay, so we break this out because in theory we can say also 1 mole, okay, of NO2 in a chemical reaction, 1 mole of oxygen gas in a chemical reaction, 1 mole of in a chemical reaction, or just simply say 1 mole in a chemical reaction. We need to compute each mole in each 1 mole of chemical reaction. Okay, so it is understood now that this rate of the disappearance of the three will be equal. Again, law of conservation of matter. So this explains why. Okay, because we treat that as equal somewhere along the way of our calculation, then we can produce stoichiometrically by applying this concept, 1 mole of chemical reaction, or 1 mole of the reactions. The reactions means the three. Okay, now we solve one by one again. Now, since we get already the individual rate, okay, we now get the individual rate, right? Now, we use also this individual rate, okay, but with respect to 1 mole of chemical reaction, but still using that moles in the chemical reaction. But never mind na the in O2, because we are computing now individually. Okay, you get the point? Something like that. So first, we need to choose the given, the 7.34 times 10 to the negative 3. We need to compute the overall reaction. Okay, rate. This is the overall reaction rate, not only the individual chupa-chuchu. Okay, now, I have the paper na talaga. So gaya ay mo kalimot ani ha. Gawas ganing patay jud mo. Okay. Okay, libog ra ba kini siya? Okay. What is the overall reaction rate? So normally you will think R, right? But this is not the experimentally problem solving that have tables. Okay? And if you use also the stoichiometric in getting that, you can never add those each individual reactions to produce the total reactions which is overall. See? So it needs the basic foundation. Okay? 1 mole of an ideal gas is just the same as telling the story as 1 mole of the chemical reaction as our basis of calculation to obtain the overall reaction rate, even though this is not a gas problem. Okay, something like that. So, individual na ha. So we have now the N2O, right? The rate of an N2O is, this is negative. Okay, okay, N2O. We will just this write as R to save time, because dN2O over dt, it will save time. It will consume too much time, and the ink also. Okay, so we have R, because that's also R. So small, the rate of chemical reaction. So R of N2O, we have now computed that one here. Okay, in the stoichiometric relationship, we obtain 3.67 times 10 to the negative 3 moles per liter minute. Then you have to transfer that here in our small r, because r is just equal to the delta change of N2O over delta change of time, technically. Okay, something like that. Okay, so 3.67 times 10 to the negative 3. Guys, are you still alive? Are you here with me? Okay, chemical engineering students or BS chemistry students. Okay, more or sciences related courses. Okay, or any engineering courses. Okay, or any science courses. This is related to physical chemistry, right? Okay, like this. We have now put negative because this is rate of disappearance. Okay, like this one. And we put also the R of oxygen gas. Okay, oxygen gas, guys, in concept and theory, this is the most abundant element in the universe. Okay, if the question will goes like this, blank is the most abundant element in the universe or in the planet Earth, your answer will be oxygen. And who discovered oxygen? It is Charles Presley. Okay, something like that. Remember the theories and concepts, to add scores in your theories in the board examination or in the different examinations in the future. Okay, something like that. Okay, not only problem solving. Okay, oxygen gas. Okay, like that. Oxygen gas. And oxygen gas is the most reactive of all elements in the universe. Okay, another information. Oxygen gas is the most reactive element in the planet Earth and in the universe. That's why we have water to drink, because of this oxygen gas. Okay, the electrons will be readily transferred to hydrogen gas during hydrogen-hydrogen bonding. Okay, so there will be a non-polar covalent bonding with each other. Review chemistry for that. That's why this oxygen gas is very reactive, really. Okay, so it's gonna be like that. Due to its reactivity, that's why it becomes flammable. Okay, because the more it is reactive, the more it will react to or highly sensitive to heat and temperature. Okay, that's the cause of flammability characteristics of oxygen. Okay, very clear, we don't have to argue in some points. Okay, like that, our oxygen gas is equals to we have already completed that one. Negative 5.0 times 10 to the negative 3. Ganon. Sorry guys, I cannot do the direct. Okay, the direct, because I don't love direct computation really. Because it may confuse me somewhere along the way. Okay, I really love systematized way of presenting the solution. Anyway, those cum laude, magna cum laude, high IQ can present directly, straightforward without showing this tuba. But the only problem on that, the slow learners and the below average students cannot understand very well. Okay, that's the only disadvantage. Okay, because in a classroom instruction, not all are intelligent. Remember that. Not all having a very high mental ability. Some of them or majority are only average. Okay, a little below average, a little above average, but only few and rare are very, super intelligent or intelligent, like I'll tell you honestly for that. Okay, so that's gonna be the situation for the population survey, something like that, of students in the entire institutions and universities all over the world. Okay, something like that. So oxygen gas R is equals to negative 5. Okay, 0.05. Okay, time check brought to you by Powder Alaska Met, 3:15 in the afternoon. 96.3 W Rock. Okay, so 5.0 times to the negative 3 moles liter minute. Okay? Okay, after that also, the NO2 na. So, gather all the rates of each reactant and product to complete the overall reaction rate. Okay, something like that. So, NO2, RNO2, okay, is equal to the given here presented here, which is 7.34. Okay, 7.34 times 10 to the negative 3. Guys, this is not negative. Why? Because the product will be added by the concentration of the reactant. It will be appearing or adding more. So that's why it's positive. 7.34, okay, times 10 to the negative 3 mole per liter minute. So as we can see visually, the only positive rate is the NO2 because technically this has been increasing concentration somewhere along the entire completion of the chemical reaction. So the reactants are, giving out their initial concentration to NO2 so that they can produce an NO2, a formless NO2. Common sense, right? Okay, that's negative. Now, overall reaction rate, do it individually. So now, this will be your basis of calculation already. So, negative 3.67, okay, times 10 to the negative 3 mole per liter minute. Okay, again, the same as with what we did in the previous, solution. We need to refer the chemical reaction because I said earlier, this is not an experimental initial method rate. There's no tables at all. Okay, so use the chemical reaction directly. So, this one is for N2O. Okay, your moles of N2O, guys, will be in the denominator. Again, the same story as what we did before. Now, I don't have to write the moles. It's self-explanatory. So, the moles of N2O here in the chemical reaction is 2. Okay, put that in the denominator. Okay, and then the numerator will be the 1 mole of overall chemical reaction. Put that in your numerator here because that is you are asking for the 1 mole that you assume of overall chemical reaction. Haba, overall chemical. I have to put OCR. Let's agree that OCR is also overall chemical reaction or ORXN because the symbol of chemical reactions is RXN only. So ORXN. So I have to put 1 mole of ORXN in the numerator. Okay. So it's gotta be like that. I have to cancel the 2 moles in the denominator because that is the moles also the same as what our basis calculation is. Cancel, cancel. Okay, ganon, choco. Okay, what will remain is the 1 mole of overall reaction with respect to dinitrogen oxide. So compute now. Like that. Okay, so 1 divided by 2, ganon. Okay, 1 divided by 2 is equals to times 3.67 is equals to, guys, 1.835. So 1.835 of mole of overall reaction, okay, over liters, okay, because this is molar per liter seconds or minute, because minute man ang atong ano. So muna na siya. Is this enough, guys, or not? Is this enough? I'm asking you for computing for that. What is the overall reaction rate? Think. Is this enough? Okay, this is negative, okay, because this appearance man talaga siya. So, you should be extra careful for the signs also, okay? 1.835. Okay, the chemical reaction. Actually, guys, this is enough. But we need also to show how to compute the other two, if it is equal or not. It will yield also the same answer because of the law of conservation of matter that, okay, the rate of disappearance of N2O will always be equal to the rate of disappearance of oxygen gas and will always be equal to the rate of the appearance of NO2 because it is in equilibrium stage in a chemical reaction. So actually by theory alone, you don't have to solve one by one. Okay? If I can solve one, it's enough already to justify the logic and the validity of my answer. Something like that. But I have to show because for the purpose of discussion, right? Something like that. Since, guys, since this is 1.835 negative, check the denominator. And the numerator denominator, this is 1 half. This is 1 half. So we can say also that one half of this N2O will be our moles per liter of the total chemical reaction. Ratio, 1 half. See? There's a 1 half in the side, 1 over 2. So 1 half of it. Okay, 1 half of 3.67 is always our 1 mole of the entire chemical reaction. Guys, by logic, the chemical reactions will always decrease with respect to time. It will never be increases, logic and common sense. Unless you will put too much concentrations in your reactant. But this is assumed to be constant initial concentration all throughout. It will just reduce somewhere at time 1 minute, time 2 minutes, time 3 minutes, time 4 minutes, and even though 10 minutes or chuba chuchu at time infinity or at time t. Okay, so it is expected that it will go back to the original concentration. It will go back to the original concentration, but it will never be less than the original concentration because it will just stop along when it reaches to t is equal to 0. You understand? For example, if you have an initial concentration of N2 at experimentally, okay, trial 1, let's say 20 moles per liter, like that, 20 moles per liter second, something, right? Okay, now, it will just go back to 20 somewhere along the way, but it will never be lesser than that when the time reaches back to 0. Okay? At first, if the time will increase, it will just reduce also at that corresponding time. But time will come, it will be reversed to 0 the time, then this concentration will also go back to the original. Okay? Something, it will never go less than the original concentration. Okay? That's the point. Okay? Now, that's why here, we have a 1.835 negative, very small compared to the N2O, which is 3 point, like this, negative 3, like this, blah, 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 chuba, chuchu, and compared to the 7.34 here, okay? So, nigamay noon siya, which is logical. Okay, as our chemical reaction completed or completes somewhere along the entire chemical reaction, it will reduce really, okay, in which it justifies our theory for this, okay, like that. Okay, this is already the answer. Okay, 1.835 moles per liter reaction over liter per minute. Okay, the overall reaction order. Okay, why we put negative? Why? Since we know also there is NO2. The NO2, guys, will be overpowered by the reactant. Overpowered talaga. Yes, because N2O and oxygen versus only NO2 in the product. Normally, the one who will carry the actual sign will be the reactant. So it is negative, not positive. Remember, positive our NO2, okay? Because it is increasing, right? Because the NO2 and the oxygen gas and N2O concentration will be reduced and passed to the product, which is the NO2. But now in here, in computation of the overall reaction rate, our question if it is negative or positive. My point is it is negative because the dominant here are the reactants, which involves the N2O and oxygen gas, which possess negative rate each. Okay, not the NO2. Okay, overpowered and dominated by these reactants, oxygen gas and N2, not the NO2. And it is always carrying the sign of the reactant for the reason is also, in case of the overall why? Because this is chemical reaction kinetics. You always base it with the reactants, not on the product. That's the second theory and concept. Okay, the first concept we put in our brain cells, okay, because there are two reactants that produces a negative rate. It is also expected that our overall chemical reaction rate is negative due to that fact, dominancy. or it dominates somewhere in our completion of our chemical reaction. The second one to prove the validity of our negative sign is that this chemical reaction kinetics focuses on the reactant's concentration, not all the time on the product. It will be used the product only as our basis of calculation, but it will never use as our scientific investigative principle and theory to prove such things. Okay? It always the reactant. That's why our overall rate reaction is negative, which is 1.835 moles per liter per minute. So that's the two reasons. It's not enough to solve only. We need to prove why. Okay? Something like that. So number two, we need to solve also the rate of overall reaction with respect to the rate of oxygen gas. Just to prove already, even though we have the answers already. Let's see if this oxygen in O2 and N2O will be equal in the equilibrium stage. Okay, which is the concept for this study. Okay, we need to understand, not only solving, it's not good. Okay, so we have oxygen gas, negative 5.05. And assure you guys, if this is the mentality, a lot will pass in examinations in the future. Okay, because it's really like this always, rigid, thorough, and basic foundations, okay, before going to the problem solving. Okay, something like that. 505 times 10 to the negative 3 moles per liter minute. I have to prove that this oxygen gas will produce also the same value by using N2O, because I said equilibrium stage or law of conservation of matter. Okay, so like this, so times. So how many moles of oxygen gas in our chemical reaction? Then if this is not equal, then I am wrong in my hypothesis. Okay, so our moles of oxygen is 3 moles of oxygen. Okay, so 3 moles of oxygen. Again, using 1 mole of reaction in the numerator. Okay, we need to follow parallelism, parallelism, meaning the same story as what we did in the first. Okay, mole of R, 1 mole, 3, okay, ganun siya. Okay, so 1 mole of ORXN. Okay, like this, cancel. So 5.05 divided by 3, ganun siya. Okay, so 1 divided by 3 times 0.00505. Okay, 1 divided by 3. Okay, times 0.00505. Okay, ganon. So pila siya. Times 0.00505. So this gonna be negative 1.68, okay, times 10 to the negative 3. And no wonder na kaani because it's not totally equal. Wait, we need to justify by theory also. Okay, wait for that. Don't be afraid. Charot! Okay? 185 times 10 to the negative 3. Okay, like this. Okay? Then if you're in doubt talaga because it's not exact to the first, then do it again. Review. Okay, oxygen gas, 3 moles, and the denominator, ganon. 1 mole of the reaction, 0.05, okay, ganon. So, para lang dyan siya, makuha dyan mo ang exact. You need to review. Diba? Ganon. Okay, like this. So, 0.000734. I review because it looks like a little bit not closer. Okay? So, it defeats our theory, right? 0 divided times 3 is equals to divided by 4 is equals to, okay, it's really like that. So, times 1 is equals to divided by 3 is equals to, okay, again, I reviewed already by using the calculator. Let to look at the answer. 1.835. That's what I told you, class. For the first press for the calculator is wrong. For the second press, it's correct. The same na with the answer of the N2O. See? That's why I don't love really the, you have to repeat again because it will be wrong. Okay, 1.8. Second press correct. Really, exactly the same figure as what I did in the first. Negative 1.835 times 10 to negative 3. Okay? Ay, Diyos ko. Diba? Mo na ako na jud naninaw nga mo siguro jud ang usual mistakes sa students or examinees before. Okay? Because first time pressing, we thought it is correct. And then second press also the calculator, it's another thing. Just like this. It's an evidence, right? Okay? So, you have to do it again pala. At least 2 times. Okay? Oh my gosh. Really? Yes. Totoo yan. Wow. Okay. For the ano na ta, for the... tapos na ta sa oxygen gas, no? So, in O2, last. Let's prove in O2 kung negative, kung 1.835 bagapon siya. Okay? Let's prove, guys. Okay? Grabe, oy. So, okay, let's go to NO2 na. So, NO2, how much you obtain here? You did not obtain the NO2 because it is given in the problem. My goodness. 7.34 times 10 to the negative 3 moles per liter, guys, minute. Okay, now, this is for NO2. So, in the chemical reaction again, okay, in the chemical reaction again, there is NO2 which is equal to 4 moles. Carry that out in the denominator so that we can cancel that out somewhere along the way. So, more moles NO2, and the numerator will be the 1 mole of ORX, and the same as what we did in the first and the second. Okay, so 1 mole of ORXN. So this is equal to 1/4 of the NO2. Something like that, right? So 1 divided by 4 is equals to times point. First press, ha? First press. 0, 0, 7, 3, 4. First press. Oh, I obtain a correct, the same as 1.835. This time is correct. 1.835 times 10 to the negative 3. Sometimes pala, in our pressing of the calculator will matter. Okay? So, that's it. Okay. At least, very close lang 1.68 to 1.3. But still, again, right? So, it doesn't prove our theory. Something like that. So, moles, letter, minute. Oh, this is now the 1.835 times the negative 3 for NO2. And the other one also is positive 2, ha? NO2 1 siya product. And negative 1.835 for oxygen. And negative 1.835 for the N2O. Guys, all of them has 1.835 times 10 to negative 3, but only the product have a positive sign. We carry the negative sign as our answer due to the reason it will decrease somewhere along the way in the completion of our chemical reaction. That's also an analysis already, because in the board examination, okay, or any future examination, the choices also will contain negative or positive. And it's only your choices you have to choose through this. Okay? For example, like this. What is the overall chemical reaction? Like that. And the choices will be A, positive 1.835 times 10 to negative 3. B, negative 1.835 times to negative 3. And then other choices. And then since you have positive and negative sign, maglibog na kaasa. Okay, that's why you need to know the theory for that. Okay, the answer will be negative, not positive. And then you're first also thinking, because it is an overall. Okay, if it is an overall, normally it is a positive because you add something. You get the point? Okay, in basic mathematics, algebra, if you add something, that will be your total. It will become a higher value because common sense, it is added. Right? But in here, it's not. Okay? It's not, because it is a chemical reaction, it will be reduced. Okay? It will become negative somewhere along the way in the completion because it started with an initial concentration, and by the time T or how many minutes, it will reduce really. So that's why we have a positive overall chemical reaction, not the negative. Right? It deviates from the mathematics, right? Okay? Something like that. So our answer will be in number 2. What is your overall reaction order? Is 1.835 times 10 to negative 3 moles per liter minute. Now, since the choices will be declared molar, go back to molar. Molar over minute. Okay? Because it's just the same. Okay. Ay, kadlok na. Ni dako, ni usara siya ka molar. You have to break it down just the purpose of solving the quantitative and stoichiometric relationship in your chemical reactions. But balance first the chemical reaction. Okay? So this 2. We get already the answer of number 2. Okay. What is the answer of number 1? Overall reaction order. It looks like difficult, right? How can we do this? Oh my goodness. How can we do this? This is not an experimental. I mean, this is on the spot really. I did not think this in the last night, just now. Okay, so what is the overall reaction order? I mixed I mixed the question. Actually, guys, the what is being asked here is only the overall reaction rate, but I added what is the overall reaction order so that I may know really what's gonna be what's going on if you try to mix this in an experimental way of computing and in the stoichiometric way of computing. So this is now, I told you a while ago that you have a wild imagination. Okay? To become an engineer, you have a wild imagination. That you have to think something, if you try to mix that out there, if you can still have a logical reasoning, or you can still solve what is being asked if you mix all types of data in one problem. Something like that, okay? And then that's the time critical thinking will arrive. You know, critical thinking. So that's also one quality of an engineer or scientist, critical thinking. And then number 3, you have to be observant. And then data gathering, always data gathering. Okay, something like that. So apply this 4 characteristics, then you can solve this type of problems. Okay, I added only what is the overall reaction order in my own invention. Okay, so how can we compute this if we try to put this in this problem? Okay, we need to dig it out. Okay, now. Because I have to prove something. Okay, so if you use this R is equals to K into O2. Let's investigate first. Okay, using this one. Okay, let's assume that the experimental way of solving will be just equal to the stoichiometric way of solving because we have no other choice. As long that it is having the valid assumption, right? Okay, so R is equal to nabuang naman ko basta R is equal to K into O. Apa yun sa libro? Okay, into O. Okay, X oxygen. Ako raw gid ni siya. Ako lang siya i-prove ba? Okay, di mo mo yung quality sa mga kuan. Wow. Okay, ganon. So R is equal to K into O over X oxygen Y. Now, if we speak rate of disappearance, what does it mean in chemical reaction kinetics? Di ba yung po R na siya? Right? So, we have now the R of N2O. So, the R of N2O equals to negative 3.67. Now, we now determine the overall reaction order of each reactant. Never mind the product because it's not related to the rate law. Okay, negative 3.67 times 10 to negative 3. I have to go back to molar na because moles per liter minute is just equal na sa molar. Okay, negative 3 molar minute. Let's just prove something here. And this is for N2O. Okay, how about the oxygen gas? Oxygen gas, we have also a rate of negative 5.05. Diyos ko, John. Nag-isod-isod na juga. So, molar minute. This is oxygen gas. Kanilang duha. Kaya mo na siya ang reactant. At ito naman ipangita ang overall reaction order. So, ganitong overall reaction order, it is the exponent in the X and Y in our rate law here. Okay? So, how can we compute this one? Hala. Nakakaloka! Okay, how can we do this? We don't have, we don't have initial concentration. Hala, okay, so, how can we compute this one? So, we have the R now. We have the R, but we don't have initial concentration in our problem. How can we do this? Okay. Di ba? Delta change in the concentration over delta change time. Okay. Now, we have the concentration because that is the numerator is the concentration. And now this is the time we relate the overall reaction. Now, if we have an overall reaction which is a negative 1.835, through this relationship, we can obtain the initial concentration. Get the point? Because we have now the 1 mole of overall reaction through mathematics, ratio and proportion. Laoy. Okay. So, solve for the initial concentration of N2O having the concept that we assumed 1 mole of overall reaction. Okay? Like that. Okay, sige. Ganon. So, sa N2O. N2O. Okay, N2O. So, like this. So, negative, our basis of calculation is the negative 3.67, having in mind the 1 mole of overall reaction order. Okay, something like that. Okay? So, okay, pwede siya. Talaga. Okay? So, if we have 3.67, okay, moles of N2O, okay, well, imagination na lang ni siya ha. Okay. Is equal to, like this, 1.835 as our overall chemical reaction negative. Okay. 1.835. Never mind the units. The purpose for the ratio and proportion naman siya. But then, we will analyze the units later. Okay. Then, we let X as our initial concentration. Okay. Tama ba? Okay, X as our initial concentration. Okay, and then, since this is chemical reaction kinetics, our total reaction is no longer the 1.835, that is half. Okay, because you know in chemical reaction kinetics, it's always like this. The final concentration is always equal to the 1/2 of its initial concentration in a chemical reaction. So it's gonna be 1/2 of 1.835. Okay, so 1/2. Okay, like this of the total entire reaction, right? Entire, because this is total man siya. Okay. Okay, final man po siya, di ba? If you say final concentration, that's also the total. Okay, final naman siya. Okay, so it makes sense. Okay, so like that. So 1.835. Guys, this is not in the book. Okay? So 1.835 divided by 2 is equals to 0.9175. So this is X is equals to 0.9175 and do the ratio proportion. Okay, at 3.67 moles of N2O will yield from the total negative 1.835. So 3.67 negative over 1.835 and then let X as our initial concentration of N2O in which this is not given experimentally. Okay, so X over and then the 1/2 of it which is 0.9175. Okay, and then times that one, 3.67 times 0.9175 equals to, divided by 1.835 is equals to, our X is equal to 1.835. Lano? Magic! Okay, so 0.9175 times 3.67 divided by 1.835 is equals to, hala, grabe. So through this computation pala, our initial concentration also will be equal to 1.835, which is also equal to the overall reaction rate. Okay, let's try the O2. Okay, this is 1.8. Okay, initial concentration, guys. Ay, kadlok. Okay. Patro man na siya gitistingan. Okay? So, an oxygen gas also, the same story. At oxygen gas, which is negative 5.05, turns into negative 3, is 2. The total overall reaction rate is negative 1.835 is equals to the x, and then we'll produce 1/2 of this 1.835, and then how much? Upatakibaw ha. Okay. Kung bisig yan ito niya siya, tinuod ni. Wow. Kaloka. Okay, ang consideration dito ng ipangita, di ba? Okay. It makes sense talaga siya, di ba? Concentration, it has yield a rate, right? And the concentration, how many rate? So, the same quantities, you should be careful in ratio and proportion na the same quantities you use, or else it will not meet the R and P principle in algebra, ratio and proportion. If it is not the same quantities you are trying to obtain. Okay? So, if, say, negative 0.05 for oxygen gas will yield the total, from the total, which is negative 1.835, and then let X as the initial concentration of this oxygen gas that will yield 1/2 of that rate, okay, on the total chemical reaction. So 1/2, because half-life man siya, okay, so mamagili siya ang theory. A is equals to 1/2 AO. Okay? Mogi na siya constant. Mogi yung permin gagamiton. Mabitaw na kay T and 1/2 of half-life because of this principle behind. I will use that also here. Okay? I am just using it consistently. Let's just prove something that what is our overall reaction order. Okay? Because we cannot solve by directly. Okay? So still gihapon siya ha, 1.835. Okay, overall reaction order man siya. So, X, mo usab na ni, sure. So, X, i-divide sila na kudaan. Okay, 1.835 divided by 2. So, 0.9175. Okay, is equal to the 5.5. I did not carry the sign because all are negative. It will just cancel somewhere along the way. All are negative. So, 5.05 times 10 to the negative 3. Okay, and then, okay, what is the total? Okay, 1.835, like that. Okay, so our X will be, okay, compute that algebraically. So, okay, 0.00505 times 0.9175 is equals to divided by 0.001835. Okay, is 2.525. Ni-increase siya. Okay? Ni-increase siya. Again, review. Because, oh my God, why the increase? Oh, let's do it again. Okay, so negative 505, negative blah, blah, blah. Okay, 1.835 divided by 2. Okay? So that is 0.9175. Right? Malong? Okay? Okay, if it is really doubtful with your answers, you need to review it again, especially if the answer is too high, it's too low. Okay, since this is big, too much, 2.25, what's really happening? So I go back here. Okay, for the N2O. So 3.67 moles per mole liter minute. Moles per liter minute is equal to negative 1.835. Okay, guys, this is negative 1.835, and this is still raised to the negative 3. See, because my brain cells work that, oh, it's very big. We are in error here. This is gonna be like this, ha? Always you have to review. Okay, negative 3. Oh, why like that I'm having this? Okay, so that's it. Okay, na kung ano na to, na intercept. Okay, the troubleshoot. So 1.001835, okay, divided by 2 na siya. Okay, 9.75 times 10 to the negative 4 na siya. Okay, 1 divided by 2 is equal to 10.001835. So, I have 9.175 siya raised to the power negative 4. Diyan na naman. Math talaga, oh, June. 9.75 times the negative 4, and this is molar. Okay, molar per second. This is concentration. Okay, Molar per second, yes? Yep. Okay, like this. Okay, muna na itong answer guys ha. Molar per second sa N2O. And then sa ano guys, sa oxygen gas, still the same. You have to put times negative 3 lang siya. Yun lang naman ang missing, di ba? To negative 3, okay. Ganyan siya, chuba-chucho. Okay. And this is 0.17 times negative 4 also. Okay, ganon. You should be careful palagi talaga. Okay? Scrutinize everything. Charot. Okay? So, ganon. So, 0.0000, wow, 9175 times 0.00, dalawa lang siya. Dalawa ba? Yes. Okay, 0.009175 times 0.0050 is equals to, okay, divided by 0.001835. Our answer will be 5.91. Okay. Ano na siya? Logical. It's not big. 0.91 times 10 to the negative 4. O, ano na siya? Atong X. Okay, ang atong X, ang atong Y. Now, ang atong into O, okay, i-substitute nimo sa rate law here. Okay, so we have the rate which is equal to, for the individual rate na, hindi na ang total because we are trying to ano man individually. So rate in N2O, okay, rate in N2O is equals to the rate constant, okay, initial concentration of N2O raised to the power X times oxygen gas raised to the power Y, and break it up to solve for each individually. So rate of N2O, which is equal now with negative 3.67 times the negative 3 here. Okay? So negative 3.67 times 10 to the negative 3, and then equal to N2O, which is, we solved that already as 9.175 times 10 to the negative 4. Okay, 9.175 times 10 to the negative 4 raised to the power X. Because this is the reaction order. How can we solve this? By calculus. Calculus, I think so. Yes. By calculus, if a number is raised to a certain variable, we need to put natural logarithm in each side. Say, it will become natural logarithm ln of negative something, negative 3.67 times 10 to the negative 3. And also in calculus, if the rule will say exponent, the exponent will go to the coefficient beside the ln. So it will become x times natural logarithm of 9.175 times 10 to the negative 4. So x natural logarithm of 9.175 times 10 to the negative 4. Now, solve for the value of x. Now, guys, this is really our unit. If your x will be illogical, meaning it doesn't meet to the positive value, because our reaction order guys is always positive value. If it is a negative value, then our analysis is wrong. Okay? If it is a positive value, then our analysis is correct. Especially if it is a whole number. Okay, now if it is not a whole number but it's closer to 1, 2, 3, and 4, then it could be accepted because the reaction order we can round it off also as long as we can have a whole number. For example, 2.999, it will become a 3. So reaction order 3. Example, 1.9999, it is a reaction order of 2. Now, if it is beyond like that, it is now impractical. For example, it's 4 something, because mostly in kinetics, it will never go beyond 3. Okay? Even though you solve thousands and billions of chemical reaction kinetics problem, it will never be beyond 5 or 4. The last will be 3, reaction order of 3 or reaction order of 4, but 4 is very rare already na. So, lalo na kung 5. Okay, that's our analysis first. So, let's solve this. And we meet our assumptions. If it really meets, then bingo. If it doesn't really meet, that means we are using here a wrong interpretation and analysis of how to solve the overall reaction order. So, if that is the case, then we will not be able to force this kind of question in this particular problem. Maybe this is not really acceptable in doing this in a stoichiometric way of solving. Okay, because this reaction order really always in the experimental way of solving manggod siya. I'll just try to prove it out. If it is still valid, to put this concept in a stoichiometric way of solving. That's my purpose. Okay, that's why I need to have assumptions. Okay, here. So, x is equals to, I have the goal, that's why. So, x is equals to the ln of 0, 0. Nakakaloka ito, no? Okay, I'm very excited what's the result. Charot. Okay, so ln of 0.00, yes, 4, diba? So 0, so 9175. Okay. Guys, actually this is negative. But the answer is negative, it's positive. Because we are incorporating negative here in the rate siya. So, understood, your final product will be negative. Okay? Then negative to negative will be positive. Okay? Something like that. Now, I will change also if I will take the negative natural logarithm immediately with 9.75. Because in that case, I put the negative last man siya. I will do first the negative logarithm first. Okay? So, let's say, kung mag-equal ba yun siya. So, natural logarithm of negative 0.00 9175 is equals to, yes, syntax error. So, meaning to say, you have to take the natural logarithm siya in the last consideration of the sign, not in the first, not in the directly substitution. In the last ba? Okay, so, like that. Since negative, negative, positive man siya, I'll take the logarithm, the final answer. Okay, also on the other side. So, 3.67, so 0.00, so, put na. Ibutang na ni mo diri. Put in the numerator. Numerator ba siya? No, denominator. Again, natural logarithm for 0.09175 is equals to, okay, 0.00, makaduda man ang results good. ln 0.0009175 pila answer, God. Negative 6.9939. Negative ha? And then, positive 3.67. Later na siya incorporate. So, 3.67. Okay. 0.003 man siya, diba? O, 67. Okay, ln. Okay. ln of 0.00367 is equals to, okay, negative also. So, negative divided by negative, so it is positive. So, this is our reaction order. But let's see if it is logical or not. Okay. Hala, I'm very excited. Okay, negative divided by 6. So, 5.6075 divided by 6.9939. Oh my goodness! Hala, x is 0.8. It's very far from 1. That is the reaction order of N2O. X is equals to 0.81. Can we round out that as 1? Okay, later, let's go back there. Let's compute for the oxygen gas. Okay, oxygen gas, oh my goodness. Layo kayo ang 0.81 to 1. Based on my computation. Okay, like that. And usually, rabano mo, ang i-round off na to, juga na rabano yung 0.9 something. To become 1. To become a first order. Okay, sige lang, okay lang. Charot! So, Kr of oxygen gas now, R of oxygen gas is equals to K oxygen gas raised to the power Y. Now, our rate of oxygen gas is 5.05 already as we computed a while ago. Okay, here. Okay, so 5 negative, okay, 0.05 times 10 to the negative 3 is equal to O2. So may concentration sa O2 in which we will try to find out. Okay, let X as our initial concentration of oxygen gas, having in mind the basis of calculation of overall chemical reaction rate, which is negative 1.835 times negative 3. Okay, so ratio and proportion. At negative 0.05 times 10 to the negative 3, we can have a total of overall chemical reaction of negative 1.35. Negative 1.835 times 10 to the negative 3. Now, at X as our initial concentration in which we don't know, Okay, it will yield 1/2 of the overall chemical reaction rate. So 1/2 of this negative 1.835 times 10 to the negative 3. So solve for the value of x. Ratio and proportion in algebra. So our x will be our initial concentration of oxygen gas. Because initial concentration is very important to obtain the reaction order. That's why we solve this. Okay? There's a correlation. So how can we do this? Do the basic math. Okay, so i-divide na to daan, i-times na to daan ng 1/2 ang total overall reaction rate, right? So, 0.001835 divided by 2, my goodness, or 0.5 times 0.001835, 1 divided by 2 times 0.001835. Ang calculator na buang na. Ang first press lain, ang second press lain. That's what I told you a while ago. Okay, klaro ho na to. Okay, 1 divided by 2. Hinayo na lang dyan na ako. Okay, times 0.001835. Okay, 9.75 ang atong side. Kini siya nga quantity, guys. So, negative 9.175 times 10 to the negative 4. Okay, now, ratio and proportion. Okay. X is to negative 9.175 times 10 to the negative 4 is equal to the negative 505. Okay, negative 505 times 10 to the negative 3. Okay, and then negative 1.835 times 10 to the negative 3. Cancels out the negative. Okay? Like that. Cancels out the negative first, ha? Para way lubog. Okay? So, ganon. So, 0.00505 times, okay, 0.0009175 is equal to ganon. So, 4.6. Okay, so 1.835 times 10 to the negative 3x is equal to negative 4.633 times 10 to the negative 6. Sure ka? Again, press again because too much high the exponent. So 0.00505 times 0.00, okay, 0, nawagtang, 0.00505 times 0.0009175. Again, ha, because nagduda jud ko, okay, okay, it's correct. Okay, divided by 0.001, sorry, pag akong gibutang da, nakakaloka. Okay, so 4.633 times 10 to negative 4, or let's say, again, for the third time, naglibog na jud ko kay, mo may exponents, I told you earlier, di ko ganahan ng exponents. Charot! Okay, 0.009175 times 0.00505, muna siya ang itabo, okay, divided by 0.001.835 mo na siya nahitabo. Okay? 1.3. Okay? Basta daghang kay 0, no, makalibog dyan siya sa 9175. So be careful. Okay? This is a purpose of discussion only. Okay? 0.00505 is equals to divided by 0.001.835. Pilay answer. Oh, x is equals to negative 0.00253. Wow, this is logical. Our initial concentration is negative 0.00253. Oh, logical siya, no? Negative siya. Okay, take note. Negative siya. Your initial concentration ay kahadlok. Okay, negative. And then, we have negative RO2 is equals to key oxygen to power Y. Substitute this negative, it will be cancelled. Okay, that's why we have a reaction order positive. Right? See, negative 505. Rate low. Kani siya ba sa oxygen gas? Do you see this, guys? Okay. Our oxygen gas equals the rate constant times the oxygen gas raised to the power y, wherein y is our reaction order in which that is the one we are computed to. Okay. Now substitute the x, which is our initial concentration of oxygen gas in which we are obtained now through relationship. Okay. So 5.05 times 10 to the negative 3 oxygen gas, ipasok na siya dito. Okay, 0.0253. Makancel ang positive, ha. Okay, ganun siya, chupa-chuchu. And then y. And then take the natural logarithm because the exponent is y. My gosh. Kalabat na naging exponent y. Okay, ang taas. Okay. Mutay mahimo. Okay, so okay, naman siya sa taas. Take natural logarithm. So, natural logarithm of ln of 5.05 times 10 to the negative 3. This is for oxygen, ha? Remember, guys, our N2O has a reaction order of 0.81, which is not close to reality because our reaction order will be 0, 1, 2, 3. And remember, 0.8 is somewhere closer to 1, but not very close. We cannot accept, right? And it's also far from 0, in which we have also a 0 order. So how can we do this? Later, we need to find another way for that. But let's solve for the oxygen gas muna. So, this is y ln 0.00253. Sure ka? Yes. 0.053. Okay. So, solve for the value of y. So, this is ln of, okay, ln of 0.00, okay, 505 ln 253. Guys, I will explain you to this. Okay, you can never cancel the ln directly. Why? Because ln is not a variable, the same as x and y. And ln as a constant is partnered with each other. It cannot breaking up. You will never break that up. Okay, so you can never cancel the both ln here, and you can never also divide the number and then you put that ln, because after that you take the natural logarithm is also wrong. Okay, so the only way to do this is take the natural logarithm individually without cancelling the same property. So it will deviate from the other concepts in algebra. If the same quantities, you will be able to cancel it out immediately, right? But here it's not. This is a calculus thing. Okay, it's not take the natural logarithm individually in the numerator and then divide it by the natural logarithm in the denominator individually. Because I tried this so many times also. That's why I learned a lesson. You will never go this directly cancelling, or later as you will do the individual taking the natural logarithm. Okay? So we'll never learn this if you will never try to solve a lot of this. Okay? So 0.000505. Tama ba siya? Okay, yes. Okay? I-logarithm mo siya. So 0.00, natural logarithm. 505. Okay. Negative. Ay, kahadlok ha. Negative 5.288. Negative ba sa ning ubos? Sure ko. Okay? So 0.00253. ln 0.00253. Negative sad siya. Muna yung muko ay kahadlok, guys, because the reaction order is not negative all the time. There's no reaction order that is negative. Then if you obtain negative here, it's wrong. Totally wrong. Okay, so that's why negative cancels it to positive. So 5.979. So y will be pila ka ni siya. Okay, so 5.288 divided by 5.979 is equals to the same. Positive 0.88 ang atong y. So having this in mind, guys, all our reaction order is 0.8 something. It is very far from 1 and 0. So we can never use this stoichiometric relationship in computing the reaction order. You get the point? It's always based on the experimental data, not on the stoichiometric relationship. Okay, so having my wild imagination to put that as a question in this problem, it is not valid. Okay, so we will eliminate this question, overall reaction order. Okay, so we can only solve for the overall reaction rate, not the overall reaction order. Then, if we try to force this question, then add initial concentrations in your problem. Okay, so that it will be perfect. But in here, I try to solve the initial concentration through this stoichiometric relationship. Maybe I got wrong also somewhere along the way in the competition, but it's not valid due to my results. 0.88 and 0.8 is far from 1 and far from 0. Since we know the fact, reaction order is starting from 0, 1, 2, 3, and the rest will be rare na talaga siya. Okay? In chemical reactions. It's not also logical to have so many reactions in the reactant, right? Normally 2, 3, okay? But never more. Something like that. Never more than 3 is something multiple na siya, and another concept will be applicable to that. I don't know pa which concepts to be used for that, okay? But in this time, it's not possible, okay? Like that. Okay, now, this is the overall reaction order we already obtained here, which is negative 1.35 times 10 to the negative 3, guys. And then we cannot solve for the overall reaction order. If you see this live streaming, suggest me how to solve the reaction order of N2O and O, guys. Because the number of moles, guys, are not the reaction order really. How about using the one half-life? Another assumption. Half-life for each. How can we solve? Half-life of zero order. Let's assume zero order, right? And then for example, still there is an initial concentration. We cannot solve because our data, we don't have initial concentration here. Okay? If we solve for the half-life. And then if we try first order, because there's no initial concentration, it's very easy. And there's also rate constant. We cannot solve because there's rate constant. Okay? So, here it's easy to drop the rate constant because it is just a constant. Okay? That's the rule in the reaction kinetics. You drop that first because that is a constant. By name itself suggests that it is a constant. That's why rate constant. Okay, so do not involve that first in your equation in the R and initial concentration just to get the reaction order. No problem with that. I understand. But for the half-life, there is K magud siya. You cannot treat that as a constant because it's in the denominator. Okay? The constant in the half-life is in the denominator always. For 0, for the first and the second order. Then, good only if it is directly proportional. In here kasi guys, the rate law is directly proportional to the K magud siya in the reaction. Okay? Nakuha niyo ang point? Diri ba? Diretso man siya directly. Okay na. Rate law is directly proportional to the K. Rate constant. Tanawan yung reaction O. So muna makaingon ta i-drop sa nato ang constant because the rate law is directly proportional with the rate constant. But in that half-life, it is inversely proportional. We cannot drop directly the rate constant to be as a constant somewhere along the way in our solution. That's analysis that we can never use the half-life in getting the reaction order. So what else can we, well, imagination. How about using the charot oy? T1 half na maingon ta. T1 half is equals to the molarity raised to the power 1 over n times T negative samot. Ang n nasa exponent iso da kayo. Wapatay half-life, wapa sa reaction order na nasa exponent ang n samot. Okay? Like that. How about try talaga? Let's see lang. Okay, try ko na to. Naman tayo sa ka-reaction God na stand-alone reaction equation na from Arrhenius. Okay, nga niingon siya nga kuan mao na siya. Arrhenius theory states that rate constant K is equals to the molarity capital M, raised to the power 1 minus n, which is the reaction order. Di ba gusto ta na reaction order ko na to? Okay, so times the T negative seconds. Wala problema ang time, kay minute na to siya per me. So, atong problema is ang K. Okay? So ang K, halaway ha, nasa to atong value sa R. La. Okay. Dito ka compute aning R, kinaamagoy concentration na, wa baya siya. Charot! Okay. Now, R is equal to this one, n2 raised to the power x, raised to the power y. We cannot compute talaga because we don't have the K actually. Okay? We cannot do that. We can try this one. Okay. We don't have also the K for here. Okay. We don't have the K. Can we drop this K? Remember, directly proportional siya sa molar concentration. Tanawa na mong formula. Okay. So let's say we drop that first. And then we have the molar concentration of ito na atong na-compute ganina pila man to. Just to find the N lang yun talaga siya ba? Ipuga jud nato nga para what is the overall reaction order this in terms of stoichiometric way of solving. Naanad ba ta sa experimental data? What if tagaan tag problema in the future examination nga stoichiometric lang siya? Mo na akong goal. Okay? For example, you are facing an examination or board examination that the problem is just like this. Okay? And then they will try to ask, what is the overall reaction order in this approach? Okay? Kinaanad man ka sa experimental lang yun siya nga reaction order nga manaata. Okay? Nakuha niyo ang point? Ganon. Okay? Something like that. Kaya usually naman dyan siya concentration, kaya experimental data man siya. What if kani siya? Wa man good siya. Wa man gigiven sa problem ng initial concentration. Okay nga. What if the question, ingon na siya nga kuan. What is the overall reaction order of N2O2 niya? Why initial concentration? Oh, mayabuta. Ay, wa man tay kuan, wa ta nangandam ba? Okay, so in this way, nangandam ta daan through our wild imagination. What if pala kung mangita siya overall reaction order in this problem, wa pa siya initial concentration. Mo na atong pugson, magitaon jud nato ang initial concentration through these concepts na we solve na. Kaya naman tayo mga relationship, na-solve naman nato ang initial concentration, in which in fact na-solve nato. Okay? Only that we solve an very far na reaction order. So mangita po siya taglayang option para lang jud ta makakita sa reaction order. Nangandam tadaan ba? Mo na siya tong purpose or our goal. Okay, give me saya na gyud na nako ha. Okay. Now, let's say lapang tayong option nga K is equals to molar 1 raised to the power n times T. Now, nakuha na magid nato atong concentration ina na tay capital N. Okay, so ang N na to wala man so dili na kay pag-solve na siya. Kaya usa na lagi pangita N ra good tanawa. Okay? So mo na siya na mo na mag-ratio proportion dayon ka. Okay, so pila man to ang imong x na nakuha sa primero guys, pila man to nagibog na jud ko ani. Wow, through wild imagination. Okay, so ang atong initial concentration nga nakuha for N2O, asa to nga papel uy? Ala sige pa, libuga gini mo to. Okay. So, mutay mahimo kay may ani man jud ni mga chemical engineer. Okay. So, pila man to siya guys. So, okay. Ang N2O na to 99.5 ang atong O2 nakuha na to be nato Asa man to papel oy? Nabuang, wa. Ala, Jonas, ano itong papel? Okay. O sige, nadrao. Okay. So, ang awang atong oxygen gas initial concentration naabaya. Okay. Which is 0.00253 baya siya, guys. Yan, negative. Muna nata. Yan, ang atong N2O, napunta. Nakuha na ni nato. Oh, di nantong labdo na itong ulo. Kinakuha naman gito. Okay. So, asa man to? So, 0.0009175 muna siya. Okay, negative sad siya kaya ito sa purity. So, natao. Ang duha na nata. Okay, so ato ko na may substitute og suway oy. Sa kini nga K is equals to M1 minus N times T para makakuha na gyud tag reaction order na nga mao atong gibutang-butang diri nga makasolve ta para in the future examination mangita gani siya og overall reaction order nga walay initial concentration through stoichiometric relationship din maka-answer ta. Okay, because our na-use naman ta sa experimental data. Kakuha mo sa point, guys. We are used to determine the reaction order, finding of it through experimental data. What if there's no experimental data in the problem solving that we face that in the future examination? Can we solve it? That's the goal in here that I'm intending to discuss to you. Okay? So, napatay last option. Okay. Solve for oxygen gas. Okay, now dropping the K. How can we drop this K in here? Oh, okay. Ganon. So, if we try to assume constant in algebra, okay, let's say constant to 1 is equal to constant to, okay. So, constant to 1, ganon. Constant to 1 or K1 in oxygen gas, right, is equal to the constant in the N2O. Why, Sir Sotero, why you assume that one? We assume that one because it's just the same in equilibrium state. Okay, in chemical reaction kinetics. The rate of disappearance of oxygen gas will always equal to the rate of disappearance of the 2O and equal to the rate of appearance of the product. So by having that concept theory, we can also apply that here in our, just to solve for the reaction order. Let's assume that that is our analysis. Okay, now K1 of O2 is equal to K of 2O. Now, we have the formula of K. So we will say this one, M of O2, lawe, M of O2, which is 0.00253 raised to the power of N, in which we don't know, okay, like that, is equal to the N2O, which is 0.00975, lawin, magkuha na sa kuan exponent, okay, like this, raised to the power 1 N, in which we don't know again, talaga. Okay, then minute. So, solve for the N. Yes! Okay, solve for the N. Okay, kaya naman common naman sa duhang N. Okay, so solve for the N. Muna na itong overall reaction order. I-break na yun na to, ibalik na to dito. So, muna to tagsa-tagsa. So, ang Engr, guys, muna ang yung overall. Let's say. Okay, gamitan na to og calculus. Applying calculus in this equation. Lawi, okay, N na ang habilin. So if there is N left common to this, it's very easy to solve to the N. N is our overall reaction order. Baya, diba? Overall reaction order sa atong ipangita. Oh, di ba? So, okay. So, laoy. So, 1 over N, natural logarithm of, pila man to, 0.0000253 is equals to 1, okay, 1 over N, ln of, ganon, 0.0000175, tulo ka 0. O, tulo ka 0 siya, kaya format siya. O, 0.9175, ganon. Okay, ato lang sa i-drop ang T, guys, because the same man good siya sa kilid o sa kilid sad. Hindi man siya bumatter. Ato na isumpot later. Or we shall carry that, no problem. Ang minute, i-carry lang yun natin, pero may problema, eh. Okay? So, that, para for the purpose of, ano lang, smooth discussion. Okay, now our solve for the value of 1 over N. Hala, kumon ra ba sa duha, makancel na po ni Ron. Okay, so let's try lang yun siya. So, ln of 0.00253, pila man siya, guys. Kakaloka to. Nakakaloka, no? So, 0.00253. Okay, ln 0.00253. Pila man siya. Negative. Hala, uy. 1 and negative 5.98 is equal to 1 and di man ba ni makancel ang 1 over n, kina sumpot man sa ln, bani ko kanina. So 0.000 ala, uy, ginawa ko. John, go. 0.00917 is equals to, okay, negative 699. Okay, negative 699. So for the value of N, i-transpose ba yan nila? Dito nito matranspose. Okay, times mo siya. Ato siya i-times, i-distribute siya tagsa-tagsa, guys. Okay, 1.n times a constant in algebra. Diba? Makangani na ganita, ikasatagsa ni mag-distribute. Okay, times man siya. Okay, so, negative 5.98 times 1, so negative 5.98. And then, positive, this is positive n, positive 5.98n. Okay, positive 0.95n. Kanisa siya, saan sa nini mo siya? So, this is negative 6.99. Okay. Mao ba? Okay. And then positive 699n. Okay. Na algebraic expression na siya. Linear algebraic expression. Transposing the negative sign into the left and then solve what is being required, which is the end of the reaction order. Wow, excited na ako. Charot. Okay, so 5.28 and minus, alaoy, 6.99 n, right? Is equals to negative 6.99 plus 5.98. So for the value of n, wala, nakakaloka, Jude. Okay, let's see. That's reaction order. Makuha pala ni nato, guys. Thank you, Lord. Okay, kasi makuha. Okay, 7.9 minus 5.98. Negative, kay dako man ang negative. So negative, nagbisaya na lang ko para madali. Negative 1.01 and is equals to, okay. Sorry guys if you cannot understand what I'm talking to, but I'm trying my very best to put English again, to use English again. So negative 0.699 plus 5.98 is equal to, so 6.99 minus 5.98, carry the sign, so negative 1.01. Okay, negative 0.01. This is n already, ha? Okay, n divided by 1.01. No? Yes! Oh, 1. Overall reaction order is 1. Hala. Our overall reaction order is 1. Nakuha na nato by having the last K of formula option. So, kung ang overall reaction nato is 1, now compute individually. Right? So, I could say, by algebra again. Hala, uy, nahurot na ako, nagbuka na ako. Okay, overall reaction order is equal to kani siya, mura man ni siya mole fraction, no? Mao ba ni siya mole fraction? Oh, mura mao ni siya. So total number of reaction order NT is equals to the N of the N2O and the N of oxygen. So pila man na siya, nanatay 1. So this is, so reaction order of N2O plus NO2 is equals to 1. Therefore, if we solve the reaction order of N2O algebra again, so reaction order of N2O is equals to 1 minus the reaction order of oxygen gas. Laoy, grabe na to. This is equation number 1. Na nasa tilaing problem, how can we obtain the individual reaction order? Saan naman na ito? Saan na ito? Individual reaction order na takin. Na naman tayo overall reaction order. Actually, mo na nagipangita sa problem. What is the overall reaction order? So, we have 1. Nya gusto mo nito mo prove kung sa individual reaction order sa N2O oxygen gas. Muna have an equation like this. How can we do this? Okay. Laoy. Nahurot naman ako equation. So, ano naman na to? So, how can we prove this? Okay, 1 minus reaction of 2O. Okay, ganun. So, ganun siya in fairness. Okay. So, okay. Wait. Okay, let's use this, the rate law here. Okay, let's use this rate law. Rate law of N2O katong standard. Okay, rate law of N2O is equals to, okay, pila man natong rate of N2O na itong nakuha na siya. Okay, we go back, which is, pila man to eh? Oh, 3.67. Negative 3.67 times 10 to the negative 3, and then dropping the constant because it's directly proportional. Okay, so N2O, okay naman, diba? N2O, okay, N2O, concentration man siya, no? N2O, and then X, which is equal to 1 minus NO2, right? Mamana siya, no? So, 1 minus NO2. Muna itong reaction order. So, naman tayo value sa N2, makuha dyan po na itong NO2 individually. So, let's try. So, negative 3.67 times 10 to the negative 3 is equal to N2O. Nakuha o naman 2. Itong primero dyan na ito. So, okay. 0, 0, negative 0.0009175. Raised to the power 1 minus NO2. Laoy, calculus gihapon. Calculus, let's use calculus this one. Okay, so very tasky, right? I think the examination will never ask this one because this is very tasky. Okay, we keep on using the principles, concepts, equations that are valid. Of course, we don't use it, it's not valid. Okay, then it took time too much to solve just because of the reaction order. Okay, but let's try. This is Uh, this is life all about. Charot! In O2. So, again, cancels. Okay. So, take ln in both sides. So, ln of 0.00367, natural logarithm. So, 1 minus n for in 2O. No, in O2, O2, di man in O2. O2, oxygen gas. Okay, times, cancel na siya, no? ln, okay, ln of 0.009175 na. Solve for the value of ln, tagsatagsaon, okay? Tagsatagsaon man dyan na siya, no, di ba? Okay, so 1 NO2 is equal to ln of 0.00367. Sure ka? Yes. Over ln 0.000917.5. So, ayaw i-cancel dito. So, kay marong ka, i-ln dyan yung sa tagsa ang number. So ln 0.00367 is equals to negative 560 ay kahadlok. Okay, 5.61 over 0.000917.5. Okay, ln 0.000917.5 is equals to negative 699. Cancel the negative, and then this is 1 minus NO2, and then solve algebraic expression, right? So 5.61 divided by 6.91 is equals to, laoy, unong gamay kayo, 5.61 divided by 6.91 is equals to 0.81. Our, dili pa ni siya n ha, ato pa man siya transposed. So 0.8811 negative NO2, and then i-transpose dito po, may mo siyang negative 1. Okay, so 0.811 minus 1 is equals to divided by 1, negative is equals to, like that. Okay, so n is equals to 0.189. So let's assume this as 0, right? Anyway, the overall reaction order is 1 man, so baka 1 ang usa. No choice. Okay, this is 0 order for NO2. Okay, if 0 order for NO2, guys, very easy. The nitrogen oxide is 1. Because we let that is at reaction order of N2 is equals to 1 minus NO2 man. So 1 minus 0 is equals to 1. So our reaction order of N2O is equals to 1. That's why we have overall reaction order of 1, because 0 order of oxygen gas plus 1 order of N2O. And perfect. We solve this number 1. Okay? Here. Okay? Hala. So, ganito pala. Okay. So, I will teach you the mechanics. If the problem solving in the future is asking for the overall reaction order, the first thing to do, guys, okay, is to use the relationship between R and the concentration. Okay? Use that relationship. Okay? Because if that you have that relationship, man good siya, guys, you can solve for the initial concentration. Okay, but take note, solve first for the overall reaction rate, because that will be your basis in your ratio and proportion to obtain the initial concentration of each. Okay, nanaka. So if nanaka ng initial concentration, okay, let's consider atong usa ka formula ni Arrhenius na K is equals to molarity capital N 1 minus N times T negative 1. Now, since equilibrium man siya ang chemical reaction kinetics, right, by concepts and theories and principles, so we can say K1 or rate constant of first reactant is equal to the rate constant of the second reactant. Now, ibutang dito ang formula in both sides and then solve for the value of N, because N1 minus N is the rate reaction order man siya. Okay, makuha na nimo ang N. That's N is your overall reaction order, in which na-satisfy na nimo ang question 3, what is the overall reaction order. Now, if you really want to solve the individual rate order, now again, go back to that formula. K is equals to molar 1 minus N times T, and then Okay, use the concept that total overall reaction order is equal to the reaction order of each reactant. So in our reactant there is 2 man siya. So N2O plus O2. But in the problem in the future, we don't know man siya. Ganituhin, ganituhin. You should do this in the same way. So I will go back again to the formula of K rate constant. So K1 is equal to N1 minus N. So na naman ka-equation because you don't know the other one. So substitute that there again and we can solve already the value of the other one reactant. And then go back again to that equation to solve for the order. So if you minus that one, you total that one again, then it will become to 1 or whatever you wanted to. So the point here and the goal here in this class, even though the problem in the future is not presented by initial concentrations through experimentation, okay, you can still solve the overall reaction order without initial concentration showing in the problem. That's the goal here. That's why I teach you how to solve that. Okay, you got the point already. Now, if there's no question like this, then it's very easy. No need to worry. No headache. Okay? I'm only expecting if this is a question like this in this kind of problem. But normally, I'm telling you, it will be done experimentally. There is initial concentration if they try to ask the reaction order. But we don't know, Manggod, if they ask the reaction order without the experimental trials, okay, of the rate and concentration. Who knows? Right? Because that is an examination. At least you have an idea how to do it. Okay? You get the point? That's the point. Actually, that is my wild imagination. It's not really in the book. Okay, it's not really that in the, in the online. I just have that in my brain cells. What if I'm gonna ask this one in this kind of another version of chemical reaction? Actually, in chemical reaction kinetics, the 2 versions talaga siya, guys. You can solve in stoichiometric relationship through chemical reaction alone. And then the other one, you can solve that through experimental data, trials 1 and 2, 3, with initial concentration and rate are given. You can just feel that problem because there's a lot of data there. Then you can feel also the other problem if there's no data. Okay, so you can depend now to the chemical reactions. At least one will be given for the, let's say, rate constant. You will just analyze and then you can solve. Okay, but it is more good have experimental data because it's easy to solve with experimental data talaga siya. Because it's very easy to graph on the x-axis, the y-axis along the way. And then this stoichiometric is something like more on theoretical compared to the experimental, which is more on actual. Okay, you can learn very actual approach how to solve the problem because there are data results. But here there's no data results, only the number of balls, like this, blah, blah, blah. And the disadvantages here, if you don't know how the chemical reactions in the first place, you will become wrong. Especially if your balanced chemical reactions are wrong. Okay, but in the experimental way of doing it, sometimes it's very easy because they show it how to they present the chemical reactions and then there's data 1, data 2, data 3, or rate 1, rate 2, rate 3, initial concentration, and then you have to find the K and there's a formula. But in the stoichiometric, like, talaga, you have to think. That's what I did now. I think a lot. And I almost give up. Right? I almost give up. Okay, because I think I have no choice already, but I still have the other formula by Arrhenius. Okay, that's why, guys, I told you a while ago, you should connect all the formulas. I'm very consistent to this. You should connect all the formulas and equations, even though the topic is not that at present na talaga siya. You can still have to employ that one there. Okay, it's possible talaga siya. You just connecting the dots. Just like here, I connect the dots here. Actually, it is not practical to, to do this because this is not experimental. Okay, and then this reaction order normally asked in experimental way of asking the question. But this is stoichiometry. But still, I try to force that to be in the approach of doing it because we don't know. Even though the approach is stoichiometric, if it's asking the reaction order, overall reaction order, I can still answer. Okay, like that. So that's gonna be like this. Thank you so much. Woo! Grabe. Okay, so the answer for this is the overall reaction order is N is equals to 1. Okay? Grabe naman to. Okay? Sakit yun akong ulo. Okay, muna siya. Okay, nga na ha, if you try to solve chemical reaction kinetics, okay, in solving the overall reaction order and overall reaction. Actually, I did not show you the alternative way of showing also the how to solve this because I did it in stoichiometric. Napag-chilain guys nga, isolve mo siya not experimentally but in another approach pa yun siya and I don't have time na. Okay? Ano ba ang time dito? Okay na, ito ikuan-kuan dito, alam mo ko ito may mga fraction. Later I will teach you how to do it also. Okay? For example, I have this equation, 2 moles of N2O gas plus 3 moles of oxygen gas plus 4 moles of NO2 gas. The rate of this appearance of this by stoichiometric way, okay, in a fractional relationship, it will become negative dN2O over dt, negative 1/2. And for the oxygen gas, it will become negative 1 over 3, okay, d oxygen gas dt. And then the product will be negative 1, not negative, positive, because it is increasing, positive 1/4 delta change of the concentration of NO2 over delta time. So, and we can solve also that through that alone, through the fractional relationship. Okay? Bingo! Not necessarily following the other steps I teach you. There's a lot of way how to do it. Okay? That's the second approach. Okay? To solve in this manner. Okay? You know, I don't have time na talaga gutom na jud ko. Okay, thank you so much for watching this live stream. If you like this live stream, then you can comment down below in the comment section. If you are not yet subscribing my YT channel, then you can subscribe now if you want. And then click the notification bell for some news updates on my secret channel. Thank you so much. Bye-bye. God bless everybody. See you later. Bye-bye. Oh my gosh. Hirap. Nahirapan si John.